Good morning, everyone. It is 11 a.m. I don't know why I told you the time, just for the fun of it. Hope everyone's going well at the moment, and I hope everyone has. I was about to say had a chance to look at the labs and tute stuff for this week, but the labs and tutes haven't happened yet. I've just noticed that some people were looking for them this morning, and we've had a little bit of an issue with the website. But the beauty is you're here watching the stream instead, so you're going to be distracted from the fact that parts of the website have fallen over overnight. So there's a few little issues there, but we're just going to try to distract you now while Tom fixes those issues. So let's just hope that what's happening in the back end with the website isn't too drastic. And by the time the 2 hours are up here, it comes back up. And if it doesn't come back up in those 2 hours, then we've probably got bigger problems than that. But whatever happens, in your tutorials and labs, if you can't see what you need to see on the website, hopefully we'll at least have just like the raw text of what's supposed to be in the tutes and labs, and your tutors will just give it to you. So you'll still be able to see all the work that you need to do, and we'll get the website up and running as soon as we can. Okay. Oh, 5 a.m. gang. I mean, it is always interesting that we always used to be like a Sydney-based university, but now we're kind of opening up a lot of what we're doing internationally, so we do have to think a bit about where everyone else in the world is who's learning at UNSW at the moment. And I do always apologize to anyone who's in a time zone where streaming this is not really good at any particular time of day. I think if there's anyone in the US right now, this would be at a horrible time, something like 5 a.m. or something like that. So we'll see how it goes. All right, let's have a look at the lecture itself for today. So, last week, recap of what we were doing last week. We continued our work with if statements. So we had a decent idea about what they were doing, but we took it a little bit further last week. And really, we're just getting to the idea that using if statements, we can decide between possibilities. So at the point in time where our program reaches an if statement, it makes a decision based on the information that it can see, and it can execute some code, or it can not execute that code. Or if you have else statements, and it can execute one piece of code or another piece of code. And I think we got to the point by the end of the week where we were doing ifs and elses and else ifs and stuff like that. So we had lots of different ways of doing it. Hopefully you've had a bit of a time to cement that knowledge in the tutorials as well. We talked about problem solving, and this is something that I think carries a little further than just computer science. It goes into engineering, it goes into even little things in life where something comes up, you're not sure what to do with it. And there may be many different ways to approach a situation, and we're looking at a kind of a technique that you can repeat, a technique that you can use for a lot of different problems where you just need to say, here are my different options, how do I weigh up my different options, which ones of these are really feasible to do, and what effect are they going to have on the situation, and then we choose between them like that. And it sounds really simple actually when you think about it, but I think when we're faced with a problem that we can't easily just sort of solve or jump over or something like that, it pays to be able to fall back on something that doesn't actually require you to really spin the wheels and think about what you're doing. Instead, what you're going to do is say, I had a basic technique for this, let me step through this technique and see what happens. I think a lot of those things are really handy, and you'll find them useful when you're in the middle of a programming problem. And what we tend to do when we're in the middle of difficult programming problems is we're juggling, in a sense. So we've got all these mental concepts happening at the same time, and we're trying to keep all these things in the air. And so the tiniest bit of extra sort of mental workload can really draw us back. So having techniques like that problem-solving technique to fall back on can be really, really handy. Then we also looked at while loops. So we looked at the idea that maybe we might need to do the same bit of code more than once. And so while loops are really, really useful, because if you need to do the same thing more than once and you don't have code that can rerun, you're going to end up in a situation where you would have to maybe copy-paste the code multiple times, which is super, super messy, and leaves you in a situation where it's hard to tell whether, when you've got a mistake somewhere, it's hard to tell which one of those repeating bits of code the mistake is in. And if you need to change code, you have to go through and change all the things you copy-pasted and change them again. So generally, I would say anytime that you want to copy and paste code, there's going to be a problem there. There's going to be some other solution that we want to use. And I'm going to teach you another thing today, actually, that can get you around the idea of copy-pasting code. So let's look at what we're covering today. So the first half today, I'm going to dedicate to the future of your code. So it's a funny way of thinking about this. Is what I'm teaching you is code style and code reviews, and these are things about how to make your code the most usable for yourself and for other humans. So a lot of the time when we're deep in and really thinking about solving problems and getting like stuff like lab exercises and assignments going, we're thinking a lot about how the computer is going to use our code and how the computer is going to understand our code. But one of the things that people don't realize when they're really focused on that is what really happens to humans with code is that the usability and the readability of your code in terms of actual hours it takes to develop something is often more important than how well it works on the computer. And this turns into like the idea of, if you can read your code really clearly, if you can see the sections and separate them mentally just by looking at your code, it's much easier to fix your problems than it is if you don't understand the code itself. So I've got some examples. I have this one big example today that's going to show you a little bit about what it's like to work with code that's not immediately understandable. So we're going to look at that. We're going to look at code reviews as well. Code reviews we can kind of do. It's hard to do some of them at the moment. One of the big things I think at the moment with the threat of COVID-19 looming over us is that we used to try to do a lot of pair programming in this course, and it's a lot harder to do that now because I know online people tend to do it less, and in person to sit right next to someone and do some pair programming is potentially a social distancing issue, unless there's someone that you already know or live with or something like that. And I think the rules are, I don't know how elastic those rules are, because even if you do know someone in the labs, you may not be allowed to sit right next to them, right? So it's difficult, but I'm going to tell you about the technique anyway, on the off chance that you get to do it. So we'll see how that goes. And then we're going to learn about functions. And as I said in the last slide, that functions are one of those things that allow us to write code so that we don't have to repeat code, and write code that can be reused in different ways. So we're looking at while loops, and we're able to reuse stuff from while loops. Functions also allow us to reuse things, but in a slightly different way. So I'll show them to you today, talking about a lot of other stuff today. So we won't necessarily get to do a code demo of functions today, but what I'm going to do is show you another concept on Friday, and I'm going to demo functions and that other concept on Friday. So don't worry if you don't understand it fully today, just try to keep it in your memory for Friday, and then we'll work on it then. Okay, quick recap of last week. So while loops is the technique I showed you about repeating code. And so we want to remember a few things about while loops to make sure we know what they're doing. So they've got a specific syntax. The syntax is very similar to if statements, where they have their keyword while, and then they have an expression that they test in the normal brackets. I think I don't have any code for them. Or maybe I do later. I can't remember. It's all right. I'm going to talk about them first. So they test something. And this is the same thing as the if statement, this question and answer idea. And if it's true, the while loop will run. And then when the while loop finishes, it will go back and test the expression again, and it will keep going, and it will keep going until the expression turns false in some way or another, and usually that's to do with something that's happening inside the loop. And then the loop will exit, and it will go to the bottom of its curly brackets, and then start running whatever code is afterwards. So we looked at two techniques for making loops, one which was going to stop after a specific number of iterations, and one which was going to stop just after a certain condition is met. Those are not the only ways to make loops work. So we have plenty of other ways, if we want to, that we can put some kind of condition in the while question in the brackets, and that will make certain things happen. So it's more open than I've shown you, but I wanted to show you two ways of doing it first that we're going to make it sort of easy to get started, because most of the time you either want something to run a certain number of times or you want something to keep running until it stops. And so if you only think about those two techniques, you can probably do nearly everything you need to in the course with them. And inside the while loop we can run anything, which means, as we saw, you can put a while loop inside a while loop, but you can put all kinds of other pieces of code inside a while loop and they will still work as well. Questions about what we're doing with while loops. When you create a while loop, the first thing to ever think about when you create a while loop is how you're going to stop it. Because I think that this week, people will notice this in tutorials and labs, is that you're going to make loops that don't stop. And so you've got to remember that Control-C key that I showed you of pressing Control-C. Will allow you in a Linux terminal to stop. So if the program's running and it won't stop, Control-C will interrupt the program. And if you've compiled the program with DCC, our compiler, so if you're working entirely in our systems, DCC will tell you exactly where in your code the program was when it ended. So it'll probably be in one of the loops somewhere in your code. So hopefully that will help you find the loop that isn't stopping. And I think I showed an example of that, if I remember correctly, where I forgot to put the iterator at the bottom of the loop, which is the thing that says, okay, advance the number one along. So it went along forever. There was also the old never going to give you up, never going to let you down that I put in there as well. So, a couple of ways to think about how we're going to stop the loops. One of them is run this a specific number of times. So we start at 0. This integer will count how many times the loop has run. And so every time we get to the opening bracket, I will tell us how many times the loop has iterated. So iterating is a word to do with looping. It doesn't exactly mean looping, but it means moving through information. So the iterator will say, I've been through here X number of times, and when it's been through there 10 times, then the while loop will not run again. Another way we could do this is say, I have a variable that says whether or not I'm staying in the loop. And so if this particular one is saying exit the loop, basically end the loop, and it's saying don't end the loop initially. So if we're not ending the loop, then we're going to go into the loop, and at some point, based on certain conditions, we could say end the loop now. And then the next time we get around to the start of the loop, we won't enter it again, and then we'll skip out of the loop, and then we're gone. So the trick is now we can have a variable that is slightly different from this one that, goes specifically through the numbers a specific number of times to hit this. Now we have a variable that under certain conditions, depending on how we want to set up the conditions, it can then say, all right, we're done now, we can leave. So it's like, keep doing this thing until we get this other option, and once we get this other option, we can leave the while loop. A decent example for this was how we were trying to correct someone's input in that dice checker that we did in the first couple of weeks. If you're trying to correct someone's input in the dice checker, you could just keep saying this input is incorrect if it's under some condition until they input something that is correct, and you go, okay, this is the one I wanted, now we can exit this loop. So people were talking about that as a possible solution. I even had in the slides as a possible solution, just keep asking people for something until they give the right answer. This kind of code is the stuff that will get you there. Okay. Move myself out of the way of the cute cat meme. let's talk about what we're talking about today. Some new stuff that I want to talk about. I think that I've taught you enough now. I mean, some people already had learnt a lot of this stuff, but I think we're at a point in the course now where you can write enough code so that you can actually confuse yourself with the code. So what we get with programs is that once it gets over about, I don't know, I'd say once a program gets over about 100 lines, you can't keep it all in your head at once. And some people can write 100 really dense lines as well. So for some of you, it's much less. For some people, it's something like 50 lines, because some people write a lot of, they pack it in. They pack in all the details, or they try to do more than one thing per line and stuff like that. One of the issues that we can get once we know how to make a certain amount of code is that we end up being able to write code where we can't remember it all, and we can't keep it all in our head at once. So you can look at some parts of your code and focus on them, but other parts of your code are going to slip from your memory, and then you're going to have to go back and reread it and figure out what was going on. So this is where we get the idea of code style. So I could be the one that doesn't care about code style, or I could be, oh, I look fabulous. Oh, my face doesn't fit there. Okay, I'll put myself outside the meme again. I was trying to get inside the meme. So, what we're thinking about when we're thinking about how to write code cleanly and elegantly is to make sure that it's easier to understand for ourselves and for other people who might read the code. So it's very, very rare that we're going to be working on our own. We're nearly always, once we get into a professional level, going to be working with other people. So making sure that the code is understandable by other people is quite important. And for ourselves, it means that it's easier to pick up in your problems. It's harder to make mistakes when your code is really structured and really visible, which all of this in the end leads to faster overall development time. So there's this funny statistic that we talk about. It comes up a lot, and it's really funny because every time I say this, especially when I say this around professional coders, they always say to me, no, it's actually worse than that. So one of the statistics that floats around, oh, hello friend, someone just came to say hi. One of the statistics that floats around is that we spend about 15% of our time creating code, and we spend about 85% of our time trying to figure out why it's not working or fixing it. And it's really interesting because that tends to be the sort of genuine cost in what it takes to make, in the end, to make functional code. So what you're going to be doing for the majority of the time while you're programming, and some of people may have noticed this while you're working in labs and stuff, it depends on how hard it's gotten so far, and everyone's going to be different, is that the initial bit of code you write is going to be pretty quick. You're going to be like, well, I think I know what I'm doing, I'll do this. And then you'll spend another hour trying to figure out why it went wrong, or what went wrong, or figure out whether the syntax was correct and stuff like that. So those kinds of things are definitely going to happen. And you will find that you'll spend more time going back over your own code than creating new code, which means that the better you write your own code, the easier it is for you to go back over it and fix mistakes or other things like that. Okay, so I want to tell you some of the basics about what we consider good code style. So things that we're going to think about, and a lot of this is just, it's nearly what you consider mechanical. It's nearly just a set of rules that you can follow. So it's not something that takes a great deal of insight. It's not something that takes like a super math brain to work out. It's really just kind of keeping things tidy. So I want to teach you the things that are simple to do. And once you can get into a habit of doing these things, they become second nature. And then you'll find that going back over your code becomes much easier. So a couple of things we're going to look at. Indentation and bracketing. You will notice that in all of my programs, there's a really specific indentation amount, and then everything that's inside another set of brackets, you can really tell that it is because it's all indented. The way we name our variables and our functions, you don't know about functions yet, but you will know about functions soon by the end of this lecture. But they're also things that we can name. And so I've got a little set of rules for how we name things. I've already told you these rules, but I'll tell you them again today. How and whether or not you're repeating code. After today's lecture, you will have enough techniques that should leave you in a situation where code won't really have to be repeated anymore. Then comments. I've been heavily commenting my code to make sure it's fully understandable. So when I'm writing code for, like the first half of this course, I'm going to write heaps of comments in the code so that someone can use the code as like their own kind of textbook in a sense for how they're going to write code similar to that in the future. You don't always have to comment like that. Comments in general are things that help explain code that might not be fully understood. But I'll show you an example of how comments do and don't work today as well. And then consistency. If you're going to pick a way to do something, you should keep that consistent through your program so that it's easy. So someone looking at different parts of your program is not going to get confused with you jumping between different possible styles. Let's have a look at something. So I've made a piece of code, and we're going to go through and look at all of these things in this piece of code, but possibly more than that. We'll see what you think, actually. Is that here's a piece of code that is actually our dice checker program, but I've named it code style bad really specifically so that you can see what it is. So let's just dive in and have a look at this code, and then we'll start to talk more about it and go through some other slides about it. So, hang on. I hadn't logged in advance. Let me send you the link to today. If you've been looking at WebCMS, you would have seen this link already, but just in case no one's there right now, that is the link to the live code that I'm going to be using in the lecture. And every time I save it here on my system, you should get the updated version. So we're in lecture 5. Okay, so let's have a look at code style bad. I guess the first thing that I've got here with this is I've specifically said this is code that is not, that we know is not good code, and it's a demonstration to show you what is or isn't working in code. So I made this 2 years ago, and I haven't updated it because as I update parts of the course, as I teach it multiple times, I update it. Nothing's changed about this because it's still bad. It didn't magically get better over time. So I've scrolled to the bottom here. This is actually the bottom of this code. There are, there are a lot of potential issues with this code. So yeah, someone's like, that's the bottom? It's like, where's the end of this thing? Yeah, it's somewhere in here, maybe. Ooh, the highlighting is telling me that this bracket here closes the main. So I know that part of this is correct. So, would you believe me? I mean, you're gonna believe me because it's like, I told you this is actually a version of the dice checker, and it works mostly the same as a dice checker. So there are a lot of issues with how this is laid out, but otherwise this is functionally the dice checker except for one little Easter egg. There is an error in here somewhere, and it's an error that would be really, really easy to spot if this was styled correctly, but as it is, it's really hard to find. I know what the error is, and I can't find it right now because I have to look through and try to identify which part is which and stuff, and it's very difficult. So let's go back to the slides for a second. So the question here is, what went wrong? And this is a serious question, right? So I got a lot of really interesting responses when I showed that, which is fair enough. I can understand your interesting responses, but we need to go a little bit better than, hey, that's a complete mess. Like there's an urge to throw it away and write it again from scratch. But that's not going to be an option a lot of the time. A lot of the time we're going to write something and say, okay, this is kind of working. I need to find a way to make this so that I can maintain it, so that I can keep working on it. But I know that things aren't quite going at the moment. So let's ask this question. What are the specific things that can make this better? This is another piece of advice that goes beyond programming, going beyond computer science, into most parts of your lives. In the face of disaster, keep a clear head and focus on what can be fixed. So you can be in a situation that is completely untenable. There's no way that you think you can get out of this situation. But that's not always the case. We don't always know the future. So the trick is to try to find a way that takes you towards a solution, or starts fixing whatever you can solve out of something, rather than getting kind of shut down by the possibility that everything can't work. So we want to do this. We want to keep a clear head, and we want to look at this code and say, all right, this is a mountain, but every mountain can be climbed in a series of single steps. So we're going to go through this and say, okay, let's find some of the things that we think aren't working in this. So opening it up to chat now. I don't know if I'm pointing this way to where I see chat, and I don't know if your chat is in the same direction. But anyway, open up to chat now. Start typing in things that you think could be changed differently. Okay, naming the variables. So we have a very obvious issue here with like int x and a and b and y, and it's like, okay, some of these we think are dice. Some of these, one of them might be a total, or is that the total? That's a constant. I don't know why. Anyway, yeah, right. So some of these are dice. I can't even remember what the variables were now. Whereas if these were named correctly, I think I'd be able to get them. Okay, so naming the variables is one thing. Space things out with new lines. Let's that's one that we can do right now. And go, okay, variables on separate lines now, that's good. We've got this issue here, where would we remember that there's a scanf there if we're only reading the left edge of everything? So let's allow these their own lines as well. Indentation, someone has said. Okay, so we have all these different, we have 3 different levels of indentation here, yet these are all just inside the main. Generally, the way that you can think about indentation is usually it's the curly brackets that tell you the indentation needs to change. If we've opened a curly brackets, it means we're going into a subsection of code, which means we should indent 4 spaces in. So I'm going to grab all of this and press tab, and that's going to indent the whole lot. This one's a bit messy. I think if I press tab, this will go to the same level. No, it went too far. I can press shift tab, and it pulls it back. But that wasn't enough, so I'm just going to do this manually. And this one here. I'm not going to go through this whole thing and fix everything. Someone said delete all. Someone said new line after every semicolon. That's a quite a nice rule that we could use if we want to. This would keep a lot of things on separate lines where we think that they ought to be on separate lines. It's not going to solve all of our new line problems. I've been able to create more problems than that, but it's going to solve some of them. It's going to start allowing us to read our code by command, if this was indented correctly. So we've got these brackets here, and we've got these multiple things on the same line. If we indent this like this, and we put the bracket under the line that opened it, this starts to be a lot more readable here. Someone's asking if we can run it. Let's they want to see whether this thing actually works. I'm just going to call it dice. It compiled. I don't know why that took so long to compile. I think just the VLab server might be a little busy right now. let's see what it does. Please enter how many sides are on the dice. Did we have different sided dice? I think we did in one of those. So we have 6-sided dice. The value for the first die, let's give it a 5. Value for the second dice, give it a 4. Roll is 9. Dice check succeeded. So the question Sire Schrödinger was asking, can we run it first? Yes, we can. And it appears to work. I mean, I haven't tested it fully, and I do know that there's something that breaks it. But, yes, so even though it was written that badly, it did work. Mostly because it's taken from me having working code and then breaking it in all the different ways I've seen people break code before. Okay, a lot of people saying things like indenting, no more than one statement per line and stuff, and spacing. So a lot of people are giving us good answers to this. So even here, this in our mind gets confused into one symbol. It's much easier to read if we put some spaces in between than visually. Even before our brain has processed what the letters are here, we can see that there are 3 symbols here. When we squish it all together, it turns into things like this, which is fine because this is supposed to be one thing. This we'll see as one symbol, this we'll see as 3, and this we will end up kind of seeing as one symbol, which is messy, and it makes our brains go a little bit weird. So spacing things out like that is good. Inconsistent spacing like this confuses us as well. So as we go through, you'll see more of like what is or isn't correct. There's some weird stuff going on here as well. Line 16 looks sus. Wait, that's not the line 16 that was there before, was it? I think I've moved it by now. Yes, more than one person saying enter after things. Sorry, there's so much chat right now. Comments, these are great. Okay, so here's a great comment. I put this comment in here because I saw this in a piece of code. I saw this in a PhD student's piece of code once. Can't remember why, but don't delete this next line. And a whole bunch of us looked at this piece of code. Like, a bunch of really accomplished programmers looked at this piece of code, and we all looked at the line afterwards and said, that line cannot be functional in the context of this code. It doesn't do anything. Why is it even there? And so we all in turn, this is how to shut down a PhD research group for an afternoon, is you give them something like this. And so we all, of course, deleted the line and tried to recompile it, and it didn't compile. We were like, what is happening? So we don't really want to reach a point where this comment is necessary. And also this comment just makes no sense. It's not teaching us anything about what's going on. So there's this huge issue here. And people saying, like, you know, a comment that just says, here be dragons or something. So, oh, can we please explain something with our comments? Okay. So there's lots of comments here. Ooh, people are discussing line 23. Line 23 is an interesting one. So the if statement that I've been teaching you is the safe if statement, where we always have the curly brackets afterwards, and everything inside the curly brackets runs if the if statement is true. The curly brackets is just a way of containing code. So if we don't contain code, the first expression after the if statement is the thing that is basically seen as being the thing in the curly brackets. The curly brackets allows us to write multiple lines, and without the curly brackets, we just have this one line. Oops, I just deleted the semicolon. So this actually will run as an if statement, but if I was to go, I don't even know what I'm supposed to do, and I expect both of these things to be run with this if statement, that won't happen. It'll only ever run the first thing that comes afterwards, which is why we always, especially in this course, we always put the curly brackets in the if statements, so that if we ever decide to change our code and add an extra expression or instruction or something like that to our if statement, we can do that safely. Whereas here, this thing definitely won't do that safely. Okay, so I might leave it there in terms of what we're looking at in the comments. I think I picked up most everything that people were talking about in the comments. Apologize if I didn't. But this should at least give you some information about what we could do to start fixing this. I mean, this is already looking a little bit better. I'd think about changing some of these variable names as well. But we won't necessarily look at that all now, because, like, you know, it would take us the entire 2 hours, I think, to rewrite that code to make it work. But I just wanted to show you some of those things. And let's see how well we went against my checklist of what's going on here. So the header comment doesn't show the program's intentions. And we would always like to see that the header comment tells people what's going to go on in the program, so that you don't have to read the code if all you're looking for is, like, what does this one do? If I'm looking through 800 programs, not saying that I will necessarily do that, but there might be some time this term where I have to look through 800 identical programs, because there's more than 800 of you, so who knows. But it's nice to be able to look at the header comment and go, oh, I'm looking at the wrong one, rather than I'm 100 lines into this code. Oh, wait, is this the one I'm looking for? You know? There were no blank lines separating different things, so without that paragraphing, people are definitely talking about spacing. It's hard to tell what different parts of the code do. There were multiple expressions in the same line, you definitely got that. Inconsistent indenting, you definitely got that. Inconsistent spacing, I saw that. Variable names, comments. So this whole block, the lecture definitely picked up on all that kind of stuff. The inconsistent bracketing of if statements, someone picked up on that as well. The bracketing wasn't indented correctly. Yeah, so people are picking up on all of these things, which is great. We didn't get this far. I think we would have to have neatened up the code a lot for us to get to the point to actually realize that there were two identical code blocks and they were written in very different ways, which made it really hard to realize that they were functionally the same. So this was check one die, then check the other die. And they were done in very, very different ways. You saw how when we did the Dice Checker 2, that we saw many different ways of dealing with incorrect die rolls. I think there's two different methods, one for each die in this one. And the Easter egg, if anyone can find it, there is some incorrect code in here somewhere as well. Someone's asking about the incorrect code. I'm not sure if anyone has seen which bit is incorrect. If you've seen which bit is incorrect and you figured it out, type in where he's behind you in the chat, so you don't necessarily give it away, but you can let me know that you know. Ooh! Oh wait, someone got it. Vanish, congratulations. Yes, this is what it is. So this bit does the dice thing. If A is less than 1, then do this mod of A. This is also incorrect, because this is only checking A less than 1 and not A is greater than maximum dice. So I think that A is die 1 and B is die 2. Oh no, it's going if A is less than 1 or greater than X. So X must be dice size and A is dice 1. And this printf scanf here, and it's telling it's outside the range. I think this is processing the first die, and then this that we haven't really looked at carefully is processing the second die, and we see this in here. So we scan into B, and then we check A. So what we yeah, Shrey, I said it too late. I should have warned people not to give it away. Yeah. So this was the Easter egg, is that we check the second die, and then we're only testing invalid values on the first die again. Except it's highly inconsistent with the way that the first die was doing things. So there's more problems. Okay, so that's that's a lot of potential issues that we can see in what I hope, when the first time I did it, was not a stupendously confusing piece of code. So we can see the difference between what was code that we thought we could use and then what was code that looks a little bit like this and makes it a lot harder to get going. When it comes down to it, your own issues with code style are going to be, they're never going to be this extreme. This is me piling every mistake a student has ever made in code that I've seen over like over a decade of teaching, and me putting it all into one program, right? So you're not likely to see that. But you're going to see some of these things in your code. So there's actually a style checking tool called 1511 style, and this helps you by giving you some hints on whether the style in your code is working on. It's going to get very angry right now. Usually when you run it on your code, it's going to have a few little things to say and it'll help you, but I think running it on this, it's going to tell me a lot of stuff. So first thing it says, okay, it's picked up the hash defines, not in all caps, and it said, okay, these are all green, saying my indentation is correct here. And so we got up to about here, and this is where I stopped fixing it. And it's saying, okay, you've got a lot of indentation errors. There's no white space between your if and the question, which is also bunching things up a bit. It's telling me a lot of issues here. Yeah, these are all bunched up. And it's saying, okay, header comment, you forgot to say who you are in the header. I think this might always be an issue when I write code, because I don't put my ZID in things. I tend to put the email address for you to contact me, but for me to know who you are in these things, your ZID should be in your header. Yeah, so these are parts of what style is trying to tell me to help me fix my indentation issues and my white space issues. And my variable names, I have some single letter variable names, so a lot of the time the variable names here they'll point out when something's wrong. Oh, that's this is the wrong way around. We'll flip it back around. We'll get this changed at some point. Shrey, could you note down that we needed to change the style recommendation here? Yeah, so this will help you, and it'll especially help you with indentation because you can just see it visually through your code. So I encourage you to run this every now and then on your code. We're not too strict on style now, but we will be marking you on style in your assignments. So once your exercises get much bigger, we're going to be marking you on style, and we're going to be marking you a little bit on style in the exam as well. So it's something's worth thinking about. I mean, like, when it comes down to it, the reason why we put these marks in specifically in the assignments is if you have poor style in the assignment, you will get less marks. Like, regardless of if we marked style or not, if we didn't mark style and your style was like this in the assignment, I guarantee you'd get less marks because you would hit the deadline with mistakes in your code that you couldn't find because you couldn't see them. So I don't know how many people saw this one, but it's pretty hard to see with how messy this area is around here. And also the variable names. If these variable names were die1, die2, it'd be really obvious, right? So, yeah, so the marks for style are there double-fold. One, they give you marks for laying things out properly, and two, they should get you more performance marks because you'll make less mistakes if the style is correct. Okay. Someone's asking if a human will be marking the style or a bot. Humans will be marking it. That style checker will be run on it first, but then there's a human pass. Because when you think about it, if you want to get around the style checker, you can roll your face across the keyboard for all your variable names, and none of them will be single letter variable names. And so the style checker won't know, but a human will know. Shrey's asking if we use 1511 style for assignments. Yes, you can run 1511 style on any piece of C code that you write, and it will hopefully give you some helpful information about some of those things. The things it won't be able to help you with is like, are your comments good? So it couldn't tell that the comments that I put in my code there weren't good because it can't read English and it can't understand it. All it's doing is doing sort of really basic C syntax checking, and you can confuse it as well. It's not an AI. It's just like, it just checks for a few specific conditions. So sometimes you'll confuse it and you'll be able to look at it and go, okay, the style program's not 100% sure of what I'm doing, but I think this is as clear as it's going to be here, and I'm pretty confident with it. Sometimes that's okay. In that case, sometimes you can talk to your tutor about that kind of thing. Okay. So we've seen what's bad. And we don't really want anyone to reach the point of what gets bad. So what we're going to do is talk about how to make it good. and how to make it good while you're building it. So this is something that I was taught in one of my previous lives when I was learning about being a bicycle mechanic. When you're maintaining something like a bicycle, you can put some oil on the chain, and you put the oil on the chain on the bike, then it runs nice and smooth. If you don't replace the oil after a while, or you don't put any oil on at all, dust and sand gets in the chain and it wears down the chain eventually. And so the chain gets worn down and starts creaking and then starts scratching itself, and eventually like it'll seize up or it'll like just break and fall off. And one of the funny things was it's really, really annoying to clean a chain completely. So if it's really dirty and you clean it completely, you have to take it off the bicycle and you have to put it in a bucket of degreaser and stuff. And you've got to leave it there overnight and all this kind of stuff. So it takes ages. It's super annoying. But if you just oiled it correctly like once a week, you would never have to do that. So this is this really interesting thing. And it's the same thing with your code. Fixing this takes ages. It takes a lot of your focus, takes you away from like creating good code. But if you'd been keeping your house clean the whole time, this is the same thing, sorry, it's not just like, I've jumped between metaphors. If you've been keeping your bicycle clean the whole time, then you wouldn't really have to do that. It's the same as cleaning your room, right? If you clean your room once a week, I gotta be honest, I don't do that. If you did, it would remain clean all the time. Otherwise, it becomes this insurmountable task. So what we want to do is we want to like have techniques we can use to make sure that we're going to have clean code most of the time, and that only every now and then we'll have to do something with it. I got tagged there. Good question. Think Mark is going to be talking about good commenting, but yes, you should be adding comments. So someone was asking about where and how much comments. Someone's saying, what kind of oil do I recommend? I think the really thin like specific bike lubes, those are the ones I use. I don't use machine oil because it's really heavy and it picks up a lot of sand and stuff. Anyway, let's not. Okay, so things that we can do. I've got slides for each one of these, so this is like an overview of some of the things we can do. So I'm going to jump straight into them and talk about them. Comments before code. This is a technique for problem solving that makes things a lot easier, and also means that sometimes these comments are going to stay there and make it really easy for you to use them. So if I've got this if-else structure that I think I'm going to use for something like the dice check, what I can do is I can say, what are we doing? We're checking against the target value, and then we're checking for success, tie, and failure. I do this first. And you may have seen, I think I did something like this when we were coding this specific example. So I can say these things are going to happen, and then I fill out both what the question is in the if statement and the body of the code there. So this means it's much easier for you to think about what code you're going to write, because the idea of the process that's going to solve the problem you've already written down. So you no longer have to think about the process of the problem. You now just write the code in between. And then a lot of this might stay there, especially this one, because the else doesn't have any code to explain what it is. These two will have a piece of code in here that explains why you're running these, and this one won't, so sometimes this comment will stay. A lot of the time, sometimes I'll just leave all the comments in, because it's like, yeah, it explains everything. Another thing we do is we name variables. Now, I've said the rules for naming variables before, but it bears repeating because it's kind of useful. So, can we describe why a variable exists, what it's for, what it can do? One of those answers, like one of those things that will help us, can we do that in a word or two? If we can do that in a word or two, then we've got a great variable name. The other thing is, if you were to give this code to another student and read the name of the variable, would they be able to tell what it's for? That's always a good test, because you might understand fully what something's for at the time you create it. I mean, generally we don't create variables without some understanding of what we're going to do with them. But if you think, if I created this and then gave it to someone else, would they get it? You know, and that's a good way to test, because that someone else is someone who at least knows a bit about programming as well. We're thinking about another student, so it's not super confusing, but also we want it to mean something to them. And that other student is very, very similar to you in, say, 2 weeks' time when you've forgotten exactly what this program was for and what all the variables were for. So it's a nice way for you to say, okay, this is how I will be able to remember what something is for when I see it. The other thing is, does it distinguish it against other variables? So when we're doing something with the dice checker, I could call something die and then call its value die roll or something. But when there's two dice, I need to actually say, oh, this is the first die, this is the second die. They need to be differentiated from each other. So those are the rules for naming variables. They're for yourself and for other people who are going to use your code. Someone's talking about subscribing. You don't have to subscribe if you don't want to. It's just a YouTube channel. And the other stuff on the YouTube channel is not part of the course. So it's just fun things. Okay, indentation. And I think people are starting to understand indentation. I've been kind of slowly exposing you to what I do with indentation. But there are specific rules you can follow. So one of the most common conventions in programming is 4 spaces for indentation, but it is not the only one. So some people use 2-space indents. There is I think it's used less, but it used to be more common to actually use 8 spaces for indents. And if you want to go what I would call chaotic neutral, you could go 3-space indents. Because some people do it, but I'm not sure why, because everyone else is doing something else. But, you know, can't fault those chaotic neutrals. They're going to get results no matter what. Okay, I think that you could probably have one of those, you know, the grids of, like, lawful to evil and, no, wait. Is it good to evil and lawful to chaotic? There's, like, Dungeons and Dragons alignments and all of that just based on what people do when they're indenting. So, if I open a curly brackets, it means I'm making a subsection of code. In order for me to visually see that subsection of code, everything in there will be indented 4 spaces. And the nice thing about that 4-space indent is I will see really clearly where this closing bracket is. Because if I want to know where this thing ends, I take its line and I go straight down from where its line started and I find where it ends. Same way in here, if I open a curly bracket, it means I'm creating a subsection of code and I will put everything another 4 spaces in. So I can see clearly what code is inside this if statement. And if I want to look for the finish of this if statement, I just go straight down through the white space until I see a bracket. And then I see, okay, this is where the if statement ends. So now we have a way of really visually seeing what is inside what. So if you follow these rules, everything that's inside a set of curly brackets is 4 spaces in, and then every time we close the curly brackets, we continue the code at the same indentation level that curly bracket's closed. You're probably going to end up with code where it's reasonably simple for you to see what is contained in what. So what is inside this if statement, what is inside a while loop and stuff. You can see it because it's pushed in a little further. That was an interesting question. Does UNSW have regulations against sharing of lecture recording? As far as I know, it's up to us. So my lectures are actually public. So some of you may have watched my lectures from previous terms and years, and that's fine. Oh, Alan's asked an interesting one there. What is the rule to make blank lines? Do I have a slide on blank lines? No, I don't, so let's talk about it. So the blank lines, I will separate sections of code that are for different purposes. So the dice checker is a decent example because you've got code for processing one die, code for processing the other die, and then code for checking the total. I will put a white space between each of those 3 sections, so you can see this code all does one job, and then there's a space. And then this code does another job, and then there's some white space, and then this code does another job. That would be my suggestion for that. In fact, that's a good question, and I think I will probably put that into these slides for future students. So thank you, Alan, for that one. Kate is asking, is this too much comments? This one is definitely too much comments, because this one is explaining how the brackets and the indenting is used. Generally, when we're writing comments in code, we're writing comments that explain something that is not super readable on its own. So usually something's readable if the code is simple, we can understand it, we don't really need comments for it. So there's definitely a way of doing too much. This is definitely too much for this piece of code. Because if you just look at this piece of code, we make a number, we check if it's greater than 10, and if it's greater than 10, we make it 10. So this is just some clamping code. You potentially wouldn't need a comment on this code at all, because it's so simple that you could basically understand it without a comment. The only reason that there's this many comments in this particular piece of code is explaining the exact rules for the indentation. Okay, another one, and this is one that we saw, definitely, one expression per line. So, I've got the next couple of examples, I've got the good and the bad. So this is one that is difficult to understand, because there's multiple expressions per line. It can be really hard for us to separate these things when we're scanning through. So we can think that only 3 things are happening in this program, whereas I think there's like 6 things at least happening in this program. So doing multiple variable... Oh, this is even in the wrong style. But I didn't change it on the other one either. I think I skimmed through these as old style that I used to use sometimes in lectures. So having these all in the same lines, especially these 2 lines here, which are both specific and different instructions, this is going to confuse people, because we tend to scan down the left side when we're looking at code and go, okay, this does this, this does this, this does this. This is a lot easier to read because you can just read it vertically. You can read step by step. One thing that people are going to get into sometimes is the idea of reducing the number of lines of code you need to use to make something happen. Please don't fall into that trap, because having lots of lines of code that are really, really readable is much better than squishing everything into one line and then never being able to fix any of the problems that are in your code. So I would suggest that this is much easier to use than this. Then we have spacing as well, and I talked about this a little bit when we were editing the other piece of code, is that if this is such an extreme example of it, it's really obvious. It's hard to see what is a symbol and what isn't, especially when you look at some of the stuff we were doing with scanf, where we have and in front of a variable and we say, okay, that is the location of a variable. It's really hard to see in this cluster in here whether this is an and b, saying, okay, we're talking about the location of variable b, versus this being a double and we're talking about this question and this question. Whereas this one here, if we separate the bits and pieces, it's much easier for us to read this as a series of questions, a series of relational operator questions joined together by an and statement, where the whole if statement will run if only both sides are true. So yeah, a little bit of space here goes the same, I guess, for vertical space that we were talking about with Alan a second ago there. Okay, so if we follow a lot of those basic ideas, we can get code that kind of, at least to a certain point, we can think of as being, okay, this will be okay. Yeah. So if you're interested in looking further into this, the course webpage has a style guide. And these are things you're going to find in any organization that you do programming in. They're like one of the first things that people will do when they're going to code together as a group or anything like that, is they'll establish a style guide so that you can read anyone's code and you'll be able to understand it. So the entire organization will be really consistent with their code. And we have one here as an example of what you might do. This is the style guide that we're going to, as opposed to when I screw up and do it like this, we're going to try to adhere to as much as we can in our code. And we're going to try to make sure that we're presenting a reasonably consistent style to you, and we're going to ask you to also code in that consistent style. It's not always going to be the same. So you could go to another institution, so you could get a job at Google or something, and you go to Google and they say, okay, this is our style guide, and you'll be like, this is different from the style guide I learnt at university. And it's like, yeah, of course. They're always going to be slightly different, and so it'll be a matter of you learning how to fit to the style guide of other people you're working with, because generally if we join a company or a research group or something like that to do some computing work, they're going to already have some code. And so we're not just going to be able to be like, I've chosen the style I'm going to program in, and I will program in this style forevermore and never change. We don't really want to be like that, right? So what we're going to do is be able to jump between styles depending on who we're working with. Yes, I said before, the assignments have style marks. Yeah. So, and again, what I was saying, our style, just one possible style for writing C. It's not going to be the same as everyone else's. All right. Break time. Yeah, I'm as cool as Ryan Gosling. So, things to remember. Code style isn't just about looking pretty, which is why my face is here instead of his. What it's going to do for you is make it easier to solve your errors later in development, because it's easier for your stuff to read. It makes it easier for you to test what you're doing, because you can separate your code more easily when you're trying to figure out which bits are working and which bits aren't. And in general, speeds up development, and people are going to prefer working with you if your style is really easy. So it's always much easier to work with coders when you can read their code and not have to, like, get into a really lengthy discussion, because you can't understand what the code is the other person's writing. All right, 12:01. We will take a break now. We'll come back at 12:06. We're going to talk a little bit about this thing called code reviews, which is about looking at each other's code, which isn't always cheating, by the way. So I'm going to tell you a little bit about that. And then we're going to look at functions, which is some new technical stuff that I'm going to show you later. All right, back soon. Alrighty, we're back. I think I just had a whole bunch of questions in the chat in the break about the exam. Just chill, we'll get there. That's my answer to the exam questions. I have answered some detail in there, but don't worry about it, we'll get there. The exam is based on the course as well, so a whole lot of the content in the exam is going to be basically identical to the content you've been working on in the labs. So it'll be the same kind of layout where the question is written the same way, the auto tests are structured the same way, and the give submission is done in nearly exactly the same way. It's going to be slightly different because it's through an exam system, but it's not going to be that much different. So we're going to be testing you on the course that you have been doing, in a sense. I guess the only questions that are going to be slightly different is if we ask you to like read some code and we ask you something about it, like that kind of thing. But I mean, if you can write the code, you can probably read it pretty well also. Someone said they have a meme to show me, throw it on the forums. There's actually a meme channel on the forums there. Okay, so let's talk about one of the ways that we can help ourselves and each other with style. So this is something that we call a code review, and it happens a lot professionally. And it involves having someone else look at your code. So when we use our compiler to check our code, when we use something like 1511 style and all that kind of stuff, we can get a lot of automated testing. And the automated testing is going to test whether our code is doing the right thing. It's going to test just pure functionality. Is our code meeting the specification that we were given to write the code in the first place? In something like 1511, where we're just sort of ramping up your ability to do things, there's a lot of auto tests where we write the tests first and we say, okay, this is how we would like you to answer these questions. But in reality, and also in the challenge, in a lot of the challenge questions and the harder questions in 1511, we won't write tests for you. We'll expect you to be able to read the specification and write your own tests and see whether it works or not. So there's this kind of scale of difficulty. Because what we're trying to get you towards eventually, when you say finish your time in a computing degree here at UNSW, is we won't need to tell you much. You know, we could give you a very vague idea of a program and you'd be able to create something that solves all the problems. At the very beginning, where we are now, we're really happy to say, okay, here are all the situations where we think this code should and shouldn't work. Can you get these things working? When you get to the end, someone like me might just say, all right, make this solve this problem. And you're like, what problem? And it's like, well, it's a known problem. You go look it up. You find out what the problem is, and then you solve it in some way or another, you know? As opposed to now where I'm just like, okay, use this technique to go through this thing, and here are the exact number tests that can help you get there. Eventually, you'll be doing that yourself, where you'll be saying, okay, I'm going to use this specific technique to solve that problem that someone gave me. And in order to see whether this technique is working, I'm going to have all my little bits and pieces. But when we're thinking about code style rather than testing and functionality, we're thinking about having a human looking at our code to see whether the human can understand it. So it's very similar to, I don't know if you've ever done proofreading or anything, where someone has written a report or an essay and they get someone else to read it, and that other person basically can say to them, I don't understand what you're saying here. You know, and that's one of the most valuable things you can ever get, is you show your code to someone else and they say, I don't get what's going on between line 120 and 130. And then you look at it and you go, right, I didn't put any comments there, and that's a really like obscure mathematical algorithm that I've taken from a research paper or something like that. And so you go, oops, okay, comment in there. This is from such and such research paper by this person. It does this thing. And then someone can read through it, and then they read the comment instead of the code, and they go, okay, we can move on. You know, little things like that can be really handy. So we can think about why we would show our code to other people and use it. So I'm talking about just be careful, right? Because we are doing individual assessment here because we're doing a course, but professionally our code is much more open. So if we're working professionally, we're showing our code to heaps of different people within our company usually, to get feedback and stuff like that. Again, though, if you're working for a big commercial company, and you started showing your code to people who are public, that could also be considered giving away the company's property, and the ramifications will be much worse than anything we could throw at you here at UNSW for plagiarism. Anyway, when we've written code and we want to show it to other people, there's a whole lot of feedback, as I said, we could get to see if people can understand our code or not. The other really interesting discussions we can get is if you're working on code and you show someone something that they have done before, they're able to tell you how they did it, and you might actually have two different ways of solving the same problem. And what's really cool is it skips a lot of the thinking that you might have had to do, that kind of problem solving thinking of coming up with multiple solutions. So you can look at the other person's solution and your solution. You can both learn something from the way the other people did it. When you're reviewing someone else's code, so you read someone else's code and you give them feedback, it's really handy because you could learn tricks for how the other person writes code, or you could look at their code style and go, I really like the way you've laid that out. Like, there's something going on here that I want to be able to replicate. So it's this idea of learning together and teaching each other. And they say that, and it's ironic that I'm going to say this in a lecture, that people, in terms of learning content only, in general, this is statistical, not per person, only pick up, say, 15% of what I'm saying in a lecture. But if people teach each other something, it goes up massively to something like 80% retention or something like that. I may be teaching the tutors more than I'm teaching you, but, that's why we have, things like the labs and things like one-on-one talking with your tutor and stuff like that, part of the reflections and stuff. So because we know all of that stuff gets ideas into your head better than just me talking at you. So this going back and forth is really handy. There's lots of different ways to review code. One of them is an ongoing way of reviewing code. You can do this with lab partners, and you can do this within your labs as well, where you're sharing and you're discussing solutions to your code. So I think one thing I can do is make sure that the rules are clear on plagiarism or not plagiarism. Lab code, bounce that around as much as you want. So when you're working on lab questions and things like that, you can say to people, here, I've got a partial solution for this lab. Have a look at it. And then you can both look at it and say, there's some interesting stuff here. Like, when we can, which we used to do when we were able to physically do it, we'd actually have all the lab work done in pairs. So if you want to do things like have study groups and stuff like that, you can actually show each other the lab code. That's okay. Just don't do it for any of the assignments or the exam, because that's the stuff where we need to basically give you a chance to prove what you can do so that we can give you a fair mark on what you're doing. But the lab stuff is actually intended for people to be like, okay, here's what I did for this, and for other people to look at it and go, that's an interesting style you've got there, or I see how you solved that problem, I did it this way, let's talk about the differences. So a lot of that stuff is there for that. I think the challenges are individual, but all of the basic lab stuff is there to be talked about in a sense. So you could work on these things together, or you could do this slightly more formal way of doing it, where you finish some code and then you ask people to read it after it's finished. Your tutors are going to demo some of this in next week's tutorial, where they will... actually, not all the tutors do it all the time, but at some point during the term, your tutors are going to say, show you a piece of code, and then you're going to have a chance to do a kind of a review on this and learn a little bit about the process. It's not super... it's hard to do, because the optimal number of people to do something like a formal review is only about 3 or 4 people looking at a piece of code, because there's this thing that happens that the more people are looking at a piece of code, the less likely they are to point something out, because they just assume someone else will point it out, and so some easy things get missed. But one-on-one is really good because you're working together on the problem, and 3 to 4 on one is really good if you want to get lots of eyes looking at your code at any one time. Um, Professionally, sometimes we even use software tools for this. So you put your code up for review, and then like half an hour later, all these notes start appearing in the particular program saying, oh yeah, I looked at this is interesting and stuff like that. Or even just like, hey, I looked at this and I'm not sure what you're doing there. Do you want to tell us more about it? And then you can see whether you want to explain it more or you want to even edit the code to make it more understandable. So pair programming is really interesting. Actually a reasonably old technique, but what it does is it allows you to basically become more than the sum of your parts. One of the things that slows down or makes it difficult for programmers is that idea that I was talking before about juggling concepts in your head. The more concepts you're trying to juggle at the one time, the harder it is for you to just sort of execute anything or create anything. And so working with someone else can make things a lot easier. So I've got the idea about at the keyboard or over the shoulder here, but I also have, if you're, say, in a breakout room, one person can share their screen, other people can watch the screen. With your mics on, you can talk to the person as they're coding. I learned this in a really funny way. So I learned this technique as a teenager because we used to play this game called Command and Conquer, and it was such an old game that in order to play multiplayer over the internet, there was much less internet back then, you'd actually have to call the other person's house, like call their phone, and have your modems talk to each other one-to-one. And the modems would talk to each other one-to-one. Then you have a one-to-one link between these two houses. That was it. Like, you couldn't actually have more than two people in a game at a time. But we had a group of 4 of us. So there were 2 brothers and myself and a friend who were playing against each other. And what we found out worked really well was one person was on the keyboard and one person was just sitting behind them looking over their shoulder. So one person's on the keyboard and mouse doing everything. And so what they were doing was what we would call the micro. So the micro is just the individual interactions of just moving things around in the game. And they're not thinking about the overall strategy and the plan or anything. They're just doing the little bits and pieces. And then the other person was sitting over their shoulder saying, hey, go back to the base and rebuild this. There's an issue over there. We need to go check that out and stuff. So they were thinking strategically. They're thinking about the future. They're thinking about the problems. One person was thinking about just the nitty-gritty. This works really well with C. So one person thinks about C syntax. They think about styling things well. They think about the structure of the program. And the other person says, okay, this is the big problem, and I know the pieces we need to create to put together to solve this. And so I'll just keep the other person on track while I'm reading them, but they will do the kind of I++ and the structure of the while loop and that kind of thing. And it means that one person is thinking about how to solve the problem, and the other person is wrestling with C as a language itself. And it's really hard to do both of those things at the same time, which is also why I said one of the nice things to do is write your comments before your code, because it means that the problem-solving thing is thought of in text, and then you switch over your brain into the other way of doing things. So when you've got 2 people, you don't have to switch back and forth. You can have one person just always thinking about the strategic side, the other person thinking about the coding side. And then what you're going to do is like swap over. I mean, in a professional situation, we would often just have one person who's better in code do the coding, and the other person is better at strategizing or algorithmically thinking, is never even touching a keyboard. And so you can get that kind of thing. But I suggest at this level, when you're learning, is swap back and forth, so that you both learn about the low-level C and the high-level thinking. But it's pretty good. It's a good way to do things. If you're going to do this for a lab, it's okay for both of you to submit exactly the same code. You can just put both of your ZIDs in it and say, we did this pair programming. But just make sure both people submit it. If one person submits it with a comment saying that both of you have worked on it, they're the only one that's going to get marks. So make sure you both submit it if you work on something like this together. So the best thing is, the code is always under review, which means that the person over the shoulder is always letting the person who's coding know whether their code's understandable or not. And generally, we usually get more work out of this than we get from 2 people working separately. You're also going to learn a lot more doing this way. So I encourage you, if you can do this, to do it. I think a lot of the time in your labs, I've been reading the reports from the tutors and also turning up to some of the labs when they're in person. A lot of the tutors are saying that people are pretty active. Like, you do a breakout room and then there's often some people talking and stuff like that. So think about trying to set up something like that where someone, it's always got to be someone first, that's going to say, all right, I'm going to share my screen while we work on this, and then we're going to talk about this and stuff like that. Or maybe ask your tutor if you can do some pair programming with someone or something like that. So if you're worried about, trying to make sure you solve the problems individually, you can say, I'm going to do some pair programming for, say, 1 or 2 of the questions, and I'll do the other one solo because I really want the practice on my own. That's fine. But a lot of the time you can share your ideas and stuff. Or if you've done something already, so you did some of the lab exercises before your lab, you can hop in and you can encourage someone else to start it from scratch. And then what you do is you talk to them about ideas as they're doing it. Like, don't just go, do it like this, right? You could do it where you give them hints and then you kind of teach each other as you go along. Or even something really cool is you've already done something, you watch someone else do it, and then you go, oh, that's completely different from what I did. I like this one better. And then you go home and you rewrite yours and stuff because it's like, oh, I learned something new, right? So there's a lot of really cool stuff we can do with pair programming. The other thing we can do is a more formal code review where it's like, okay, code's kind of finished. The reviewers are going to read the code and they're going to help you with it. I think one thing we do need to remember when we're doing this, so if you do it this way, and this is something that's more likely to be facilitated by your tutor to do this because it's slightly more a formal process, is just remember not to get picky at people because it's an easy way to kind of shut down collaborative thinking and working together and stuff like that. If in a code review someone just goes, you did that wrong and that's wrong and that's wrong and everything's wrong here, right? Like, if someone is putting their code up for review, they probably know that part of it is wrong and they're not really looking to get just pointed at. What's more interesting is like how we can help people to get places. So one of the most interesting things that people often hold back from talking about is they don't understand something. Because sometimes it's really difficult for you to look at something and go, I don't get what you're doing. Because it feels, sometimes when we say that, it feels like it's our mistake. It feels like, oh, I don't know anything about code, so I shouldn't say that I don't understand something. We're trying to hide the fact that I don't understand something. But that's actually one of the most helpful things that you can do in a code review is go, I don't understand that bit. Because that actually tells the other person a lot, not just about whether their code actually is understandable, whether it's working or not, but it's about how they're writing it. And they might learn that like a lot of the ways that they're writing code isn't a way that should be understandable. It's not difficult to use, but it's something to do with the style or something. Or maybe it's not commented somewhere, or the context hasn't been set for it, and then you want to learn ways of making it more understandable. Another thing that's really interesting is if you have different viewpoints on how to solve the problem, both the reviewer and the reviewee can learn a lot from talking about different viewpoints. And then sometimes we're going to have the situation where someone will put a code up for a review and go, I couldn't solve this piece. Like, there's this part of this that I don't know what's going on. Does anyone have any help here? And people can say, oh, I think the direction your code is going, you could continue this like this and try that. And if you want to, you can, rather than, just throwing code at someone as the solution to their problem, you can talk to them about different techniques that might solve it. And then you can all kind of learn not from a specific solution, but learn from a general solution that can be applied for more than one thing. So lots of cool things we can do in code reviews. That's a little reminder, things not to do in code reviews. Your code is bad. You did this wrong. Here are all the mistakes, right? So these kinds of things are going to make it more difficult for us to all learn from each other. So I want to hope that people are more into this part of how to help each other rather than just like pointing out all the negatives and making people feel bad about their code. I don't think we need other people to feel bad about our code. I think if we're in that that time distribution of say 15%, um, uh, sorry, I was going to say 15% creating code and 85% trying to figure out why it's working or not working. We already all think our code is bad. so we don't need reinforcement for thinking our code is bad. What we need is constructive help to make it more understandable to other people, or to improve it in some way, or to discuss different options. You know, all of those things are going to lead to a solution, but just kicking someone while they're down is not going to help. It takes a lot of what I'd call like social bravery to put your code up for review. That's why in a lot of companies it's going to be sort of mandated that everyone's code gets reviewed regularly. But even if it is or isn't mandated, it's very, very kind of confronting to put your code up and get a lot of people to poke at it. So I think we always need to be aware of that. If we're going to look at someone else's code, someone's brought you their code to look at, it means they're going out on a limb and they're putting a piece of themselves out there to be judged. So please be gentle with that. Okay, I have a lot of details here, but I think I have already spoken about this. So I'm going to leave this slide as text that you can read later if you're going back over things and stuff. But just an overview, it's really the same points I just said. It's tough to put your stuff up there, so let's not judge everyone too hard. We're trying to help everyone learn. There are different ways to solve problems. Discussing the different ways to solve problems is very, very good. You will learn a lot from other people if they have a different way of solving your problem. Even if you never use their solution, you'll still learn something from it, because you might get into a situation where their solution works for something else, you know, or even just the awareness that there isn't a single solution to every problem. There are multiple solutions to every problem. That opens your mind up to being able to solve more problems. And the key one, which I've now said multiple times in this lecture, is if you don't understand something, it's a really, really useful thing to say in a review, because either you will learn from it because someone will explain it to you, or you will help someone to clarify their code in the future for other people not understanding it. Okay, I'll get my face out of the way of the text. I don't know if this is definitely happening in next week's tutorial for all the tutors. It depends on time constraints and stuff like that. But a lot of the tutorials, at least sometime during the term, will do at least one code review so that you can see what it's like. So your tutor will show you some code and step you through how we would potentially analyze this code and how we would help someone with it and stuff like that. So as I said before, you can review each other's lab work and things like that. So the labs are pretty specific. They will say which things can be done in a group and which things are individual. Generally, I think all of the lab questions will be things you can work with other people, except for the challenges, when then the challenges will specifically say individual. So you can see which ones you're allowed to discuss. And also, please don't do any discussion about assignments in the exam. The assignments, you can consider to be a journey that you walk through step by step to complete. If someone shortcuts you past things, you're going to miss out on important stuff you're learning through there. So the assignments are structured in a slightly different way. They're made to take you through a lot of different problems in escalating difficulty. So if someone shortcuts you past the easy ones to the hard ones, all you end up in is like in a hard place where you don't know where you're going. They're supposed to lead up to those things. So just be careful like that with assignments, but lab work is a very good time to practice this. I mean, it's difficult, right? It's just because we're in a university system where everyone has to get individual marks. Otherwise, if we weren't in that situation, like, I probably wouldn't have anything that was individual, because I don't think I've ever, like, in all the work that I've done as an engineer, I've never worked alone on code. So, and I've never worked, even if like there was a section of code that I was writing that no one else was working on, I would still bounce the ideas off someone or get someone else to be over the shoulder pair programming just to look through what I'm doing, right? So if we didn't have to give you all individual marks, we wouldn't even have this limitation where the assignments and the exam had to be individual. But Since we're in this situation where each one of you is going to be judged on the merits of your own capability. That's why some of these things won't be discussed, but we want to make sure that you're still learning about how to discuss code with other people. So that's why your lab work is going to have as much conversation as you can about it. Okay, so that's everything I was going to talk about in terms of code style and code reviews. Hopefully a lot of this stuff gives you an idea about how to write and structure and how to work with your code so that so you can learn how to work with other people, and also even work with the other person, which is future you. So future you is always going to be looking back at your code and saying, what did I do here, and how am I going to use it? Or how am I going to fix it, I think is the biggest question that future you has about your code. Always fun. So, we're going to introduce a new concept. I've got about half an hour left, so I'm not necessarily going to do a big code demo on this, but I think I do have some code that I've put on the website. I'm not sure if I put it in the live directory, so I'll check it in there afterwards. But we're going to talk about functions. So, functions are another coding construct that happens in C. And the funny thing is, we've actually already been using some of them. So the main that's in our program is a function. So we've actually already, in a sense, learned how to write a function. Having said that, I just told you to just leave it as it is, assume that it works, and then we'll go through later and explain it. Now we're in later, so I'm explaining what these things are. So printf and scanf are also functions. So not only have we learned how to write a function, we've learned how to use functions already. So hopefully a lot of what I tell you here is going to just clarify what's going on with these things rather than needing to teach them to you from scratch. But let's talk about what a function is. So a function is a piece of code, but it's a piece of code that's actually separated from all the other pieces of code that we have. And it has a name to identify it. So it's the same way that our variables have a name to identify it. But instead of a variable, so variables were just data that was stored in memory, so a number that we'd saved. At this point, we've only used numbers, but pretty soon we're going to branch out into words and letters and stuff like that as well. That's also going to be stuff that we can save in our memory. A function's slightly different. Is instead of it being information that's saved, it's a series of instructions. So a function is a series of instructions that we will give some information to. That's the kind of input we could give to the function, and it will do some kind of programming work, and it may or may not give us some kind of output. So we also may not give it any input as well. There's different functions that can run with or without input. We'll go into the details when we get deeper into these, probably on Friday. We call it calling a function when we ask the function to do its work. So when we ask the function to do its work, we call it by name, which is why we give it a name, and we say, hey, can you do that thing? So let me show you a little bit of how that works. So our main is also a function, but as we know about our main, we go line by line by line through the main. So when we go to, say, a function like printf, when we do printf, there's more going on than what you can see right there, yeah? Because printf is just one line that has some text in it. It's not really clear when you look at it how it's getting that text onto the screen. There's actually a whole lot of code that makes that text go onto the screen. So what happens is, when our main sees printf, or any function, that's the function getting called. And then the function's called, and we give it some input, and that's everything inside the brackets is the input. That gets given to the function, and then the function goes to its code. And it's separate from the code that's in the main. It's code that's somewhere else. And then so we jump out of our main and we run the function. We run the function until it finishes, or until it says it's finished. There's ways of doing this. I'm going to tell you about this in a sec. And the function will do its stuff, and then bounce back to the main. This arrow isn't entirely accurate. It's just made to look pretty. It will always jump back to exactly the point it left, and then it will continue going. So that's why when we think of running a printf, we go the printf runs like a line of code, and then after the printf is finished, the next line of code below it will run. So this doesn't jump somewhere random in the main, it jumps exactly back to where it was. If we're giving information to the function, it gets given in the brackets to the function. if there's information coming back out of the function, as the function has an output, it basically transforms the function into that output. In the same way that we can do a maths expression, we say 1 plus 2. When our code is run, it's going to see 1 plus 2 as if it's a 3. The functions are going to work the same way. So it's nearly like those maths operators are functions in a sense. So separate piece of code. When it sees its name in here, it runs, and then it goes back only after it's finished. We'll look at the details of exactly how we put these together as well. So functions have a specific syntax. This is if we're going to write a function. And we've seen this a little bit before because we've seen the main function, and the main function was set up very much like this. So the first thing that we have is the function's type. This is what the function will basically transform itself into when you call it. You can think of it also as the output of the function. This is the information that comes back. So when our program said int main, and we were doing stuff like return 0, that was us saying that when this function finishes, this main function, we're going to get a number out of it. And return 0 was our way of saying when this function finishes, if it gives 0, then that is the number that says that this function ran properly. When we're using functions for other reasons, like say this one here, I've made a function. It's a very trivial function. I would never have to actually use this because there's only one bit of code in it. This is a function for adding two numbers together. And I'm going to talk about the details in here about how this all works. So the output is an integer, saying that if I add two numbers together, I'm going to get one number. So I have one number as the output. Then I've got the name. So if it's going to add two numbers together, it might as well be called add. And I can say, in these brackets here, in this function, are the inputs. And the inputs are the pieces of information that are going to go into this function to get used. And so what this will basically create is two variables inside the function. So the function will have a variable a and a variable b. Both of these are integers. And this information will be given to the function whenever we call the function. We will always have to give it two integers, and it will be able to use them to do its addition. Then we have the return keyword, which is very specific, which is going to end this function, but not just end this function, it's going to return something to whatever called it. So it could be another function, usually it's the main function, but sometimes we can layer functions. So this return says, I will give back the result of a plus b, so this is what this integer will become. So these two integers come in, the return gives back this integer. And these can get much more complex than the curly brackets here. So we can throw in like 20-30 lines of code of doing stuff here. So for example, we could have a function that checked whether a die was outside of a specific range, and then corrects it. And we'd even have this same starting line, everything except for the name, because we could have, this is the number we were given, or maybe we'd have more integers here, and this is the starting range, and then we'd give back something that was in the correct range, you know. So a lot of things like that we can use functions for. The return keyword is very important for functions. So when functions have a value they will return, it's actually possible to create functions that don't have a value that they return. Return will give back the output of the function. So when we see the return keyword inside the function, at that point the function will say, oh, I've got the information and I'm going to give it back. So I've got the information, I'm going to give it back. In which case, once the function has given back the information it was supposed to give back, it will stop running there, and then it will go back. So the function will finish anywhere where it sees the return. So this means that there are possibly ways to make a function return before it's finished running all its code. Maybe hit certain conditions where it will return. But the most common place, and probably the easiest to read and the most common place we're going to see the return, is just at the bottom of the function. So it's going to say, I do a bunch of calculation or bunch of instructions, I do a bunch of work, and at the end of the work, I give back the result, you know. So that's most commonly where we're going to see the return. So that's covering how we write functions. The other thing is how we use functions. So this is this bit of code here is assuming that the function already exists. So we're assuming that our computer knows that the function exists. We're going to talk about that in a second. And if our computer knows that the function exists, knows that the code exists under a certain name, we can then use it. So if the add function, this one, has already been written and the computer knows about it, we can then run this in our main. So we can say, here's my main, here's my first number and a second number. So I'm just making these up, right? And a total. And I can say the total is now equal to the result of this function. So I call the add function by its name. So I know it's called that because I created it. And I know it has a first number and a second number in it. Well, it has two integers. It actually thinks of them as A and B, and we think of them as first number and second number. So we take the 4 here, and the 4 goes in here, and the 6 goes in here. When this thing runs, it actually makes new variables. It doesn't use these two. It makes its own variables called A and B. It does whatever calculations or whatever it's going to do on A and B, and then it gives back something. So when it gives back something, this function here basically transforms into that. So 4 and 6 go in here. We create new variables. A is equal to 4, B is equal to 6. We add 4 and 6 together, we get 10. This integer here replaces the function call. So that integer that equals 10 is what this function will evaluate to, in a sense. And then that 10 will get stored here in the total. So that's how we're going to be using functions. Ooh, a lot of chat there. Shrey, I'm going to assume that you're watching that. Oh, that's a really interesting question. There could A and B exist somewhere else outside the function and not be affected? Yes. If we used A and B outside and we've got an A and B in here, we can follow that rule of saying what goes on inside the curly brackets stays inside the curly brackets. Because this add function is not in our main, it will not know anything about the variables that are in our main, except if we give it certain values. So it's going to know the number 4 and the number 6. It's not even going to know that there's an integer called first number or an integer called second number, because we're only going to give it the 4 and the 6 from them here. And if we had A's and B's in here, it wouldn't affect these, because they're in a different set of curly brackets, and so they have their own knowledge. It gets more subtly different if you open curly brackets inside the main and start using the same variable names. Then things get messy. Yeah. Okay. So this is how we would use a function that already exists. Now we need to piece all this stuff together and say, how do we write a function within our code so that it can be used in our main? And then how are we able to then call it in a main? So we can see how we can call it in a main. Now we need to set it up so that we can use things. And before I talk about that, I need to talk a little bit about how our compilers are going to read our code. Because I don't think if we don't have the understanding of how the compilers read the code, we're not going to know why I'm doing the thing I'm doing next. So, a compiler is going to read our code top to bottom. It's going to read our code top to bottom once, which means it's never going to read our code and then go back and reread our code. It's only going to read our code once, which means if it hasn't seen something above something else, then it won't know what it is. So for example here, I've got the number 1, and I've got the total equals number plus other number. And then I have other number here. Because we're going line by line top to bottom, this other number won't exist before this line. Which means here, if I'm trying to add number to other number, if I was to read this as a human, I can go all the way top to bottom, and then I can go back to this line and I say, oh, other number's 5, and number is 1, total is equal to 6. Your computer's never going to do that. Your compiler's never going to do that. It's going to go top to bottom, and at this line here, it's going to throw an error, and it's going to say, I do not know what other number is. You're trying to use a variable that has not been created. So at this point, it's going to have this issue where it says, I can't use this because it doesn't exist yet. And we're going to get the same thing with functions, where if our compiler has not seen the function, at least seen it defined in some way so that it can use it, it will not be able to use that function. So this is actually the reason why the include standard input output.h is at the top of our code. So for us to use printf and scanf, we need the include to be above the main so that all the information about printf and scanf, and there's a whole lot of other stuff in there, but for the moment we're only using printf and scanf, it knows that those functions exist before we get to our main and we start calling it. Yeah. So we're going to do a particular way of doing this where we are going to declare functions before our main, and we're not even going to do the full function before the main. We're actually just going to say, hey, there's something called add, and it takes in 2 integers and gives back an integer. You can now do whatever you need to do in the main to make sure that the rules and the syntax for using this are correct. You don't need all the code up here. We're going to put the code down at the bottom of our code. Several reasons for this, but I'll talk about them. I'll talk about them in more depth later. But this is the way that we're going to be doing it. Well, what we're going to do is make sure that before our main runs, it knows all of the functions that are available. And then after our main, we're going to actually write all the functions. And this is where we can have all our separate pieces of code. It's nearly like this stuff is an appendix to the story, and the main is the main story. So this is where we see stuff happening. And then if we want to be really sure about what this add is doing, we can go look it up. And we go, okay, at the end, after all of this, I can look up the details for the add. This bit here is the bit that says the add function exists, so it can be used. So this is the way we're going to be splitting these things up. There's a lot of details in here that subtly make this the best way to use functions. Because one of the questions I always get when I show this kind of pattern, this kind of layout, is people ask, why isn't the function up here? Why don't we just put the whole function up here? And it gets the answer gets really complicated, because if you have multiple different functions and they use each other, having them all up here it makes it really difficult. But having them all declared first and then having them all use each other down here after they've all been declared means we'll never get a conflict about which one should have been ordered first in the list. So we just throw them all up there, and then we use everything down here. And our main knows that when it sees add like this, it says, I know that this exists, right? And I know this takes 2 integers and gives 1 back. So I know if there's an equals, this has to be an integer, and these 2 have to be integers. They either are integer variables or even just values. You could use just a raw number in these, and it'd be like, okay, that's an integer, that's fine. So because it knows this, it knows whether to verify that this is the correct thing or not. And then it won't have to know what it does until it runs. So your compiler will first go through all your code and read it and transform it into the program that you can run. And then when it runs, it's going to come straight to the main first. It's not even going to read that. It's going to come to the main. And it's going to do these instructions. And when it hits this one, it's going to say, I'm supposed to do add. I will look through everything that was compiled for the word add. It won't be the same word once the computer's thinking about it, but we can think of it that way. I will look for the word add, and I'll find its code. I'll run its code, and then I'll jump back to here once I'm finished, and then do whatever else needs to be done on this line, and then keep going. Right, so that's the details about how that code is done. So I was just looking at chat, and it's like, someone's asking a question, and someone said, did Mark just answer that question? So I'm just going to assume that I helped something that was happening there. So that's the explanation. So this layout is the kind of thing that we're going to use for functions. I will tell you more about this on Friday. We're going to use this, and we're going to potentially write some code that has more than one function in it and things. But don't worry, we're going to keep going with functions. We're going to see them again and again and again, and you will get a chance to play around with these in your tutes and labs as well. I want to talk about some other functions that are quite useful. Sorry, I actually do want to fix my style here because it's annoying me. This happens sometimes. So there's a type of function that doesn't give back any information. And it's very interesting when it doesn't give back any information. Because you might think, why are we doing a function if it's not going to return anything? And sometimes functions are used not for what data they could give back, as in the return. So for example, this add function is all about its return. It doesn't do anything but give back the sum of two numbers. So it gets transformed into the sum of these two numbers. And here in the code, the sum of these two numbers will appear, and it can be stored in total. But sometimes you have functions that say void here, and the void is the emptiness. A void means there's nothing there, but at the same time it's a keyword to specifically say that there's nothing here. You've seen this word before, right? Because the void is used here to be super clear. You don't even need void. You could actually put nothing in your int main, it would still run. But this makes it really explicitly clear that there's no information going into the main. So the main is starting without any information. Later on, we are actually going to talk about how to give information to our main function when it starts running. But any information that we want to put into this program, we're going to have to do with things like scanf or other things. We're going to have to ask for user input. You get deeper into programming, we'll learn how to read files off your computer or read information coming in from a network connection and stuff like that. But for the moment, our mains don't take any information in, and that's what this void means. Void means there's nothing there. Oops. Void function's here. So this void means I'm not going to give anything back. So all I'm going to do is I'm going to do this thing called print add, where I am still going to total up what's in A and B, but the purposes of this function was not necessarily to give something back to the rest of the program to use. It was just to output this thing so my user could see it. Sorry, I shouldn't use those keywords, right? Output means two different things. There's output to the user and there's output back to the program, to whatever called the function. So it gets a little awkward when we think about using the word output for different things. So this is printing to terminal. This is returning to another function. So we're not returning anything to another function, but we're printing something out to the terminal. So sometimes functions have a purpose, and they will do that purpose without giving any information back. So you notice the void function has no return statement. And I said the return statement was going to end the function. These functions just end on their curly bracket closing, because they will do everything that they do in here, and they will never actually give any information back. So we can use these for things like, a lot of the time we'll use these things for just stuff like print statements, and sometimes there are functions that we need to just do some work that we don't need to hear back from. So we just like, go do your work. When you're finished, we'll continue with the rest of the program, but really all we're going to do is just let you do this. So the void function type does that, and we haven't seen void as a variable type before as it is here. So it's like a non-variable in a sense. So these are the different types of functions. I'm sort of squishing in the learning about functions here so that I can do a code demo on Friday on them. I apologize that I don't have a code demo for it here, but if I check, I think I left that particular code in week 3. Yeah. There's a demo for code for functions here in the in WebCMS for today, so you can see that there. All right. Oh, I'm a little bit early today, but it's not too bad. So, what did we look at today? We looked at code style. Hopefully, I've given you some techniques you can use to make your code more understandable and more reusable and able to be fixed more easily. So there are some simple tricks there to make your code more readable. Talked about code reviews as well. I hope people are excited to maybe do some pair programming at some point during the course. This is mostly going to be up to you to find someone in your lab who you can work with. Often you can just do this randomly, or if you really want to, you can ask your tutor and they may be able to find someone to work with you. Or even better, you can ask your tutor for a code review and your tutor can say, all right, next week we'll put your code up at the start of the tutorial and we'll talk about it with other people. So we'll try to do it that way if you want. And we also looked at functions, which is our way of splitting code up so that we have separate pieces of code that we can run and we can rerun. Another thing I should say as well, if I have this add here, it means I can call this add multiple times. So, and each time it will do the same thing, but it might be different based on the numbers we give it. So this function we've created here is now this little self-contained reusable bit of code. So you can already hopefully see places where we could use reusable bits of code. And what tends to end up happening once we get good at using functions is heaps of the nitty-gritty is pushed out into the functions, and then the way we read our main is just like, do this function, then do this function, then do this function. And we can read the English words for the functions, and it's actually really easy for us to see the flow of the program like that. The ultimate goal is the short main, long function section. So the main is like 5 lines long, and the functions are 1,000 lines worth of different functions. Some of them even calling each other and stuff like that. That's like kind of one of the nice ways to style your program, because it's like you've got a table of contents in the main, and then you only go to the functions if you really need to know the details of how those things were working. Leave the functions with me. We will look at them again on Friday, and we will think about how to construct them in a program that's running. Well, not running. In a program that's in development. So the trick is going to be, we write some code and we go, okay, that code does this thing, but we think that that code might be useful to run again in another place. So let's put it in a function and stuff. So I'll show you that as it goes. All right, wrap it up there. I will go into break mode and I'll be back in a sec in case anyone has any questions. If anyone wants to poke at that function code afterwards and see it running, I'll stick around and maybe show you a thing or two. It's not going to be too much though. I think a lot of what we're going to learn about functions I'll do on Friday as well. But that will be the end of the official lecture here. I think this is the first time I've ended on time. I think I ended up dead on time once, but this time I actually ended a minute or two before, which is good. All right, I'll be back. If anyone has any questions about the code or about code reviews and code style and stuff like that, I'll come back and answer your questions. Alrighty, I'm back. Thank you all for the thank yous. I assume most of those people are probably left by now anyway. So, did we have any post-lecture questions? Any questions about the lecture or about anything we're looking at? I mean, especially I guess we're probably going to have some questions about functions, but I guess also the answer to those questions is we're going to look at building that code later on this week. Waleed saying the real 1511ers stay back afterwards. Not everyone has to stay back afterwards. Sulux is saying, does every C program have to have a main function call? Yeah, it does. So, there's a subtlety there, actually. So, every program that we create that we expect to be run will always have a main, because when we do like / program name, this is exactly where it jumps. It jumps directly to this line. No matter where it is in the code, it will always jump to this line and start running it. We always, when we're putting all our functions in our code, the main's always the top one, because we want to make sure that people can find it, right? But you can actually write a lot of C that doesn't have main functions. So for example, printf and scanf, the standard input-output library, that doesn't have a main in it. So you can't just take stdio.h and compile it and run it. Nothing happens if you do that. It's designed to support another program. So your program has the main, and those C files, they're not programs, they're actually called libraries, have lots of stuff in them, but they don't have a main joining them all together. So I would say that every program that you write in C has a main, but not every file that you write in C is going to have a main in it. From your perspective, though, you can think of everything you write is going to have a main, or else it won't run. Waleed's asking what keyboard switches I use. It's Cherry Red wait, is it called Cherry MX Red or Cherry Red MX? I can't remember. Something like that. They're pretty famous, those ones. I'm not sure why you're asking that. Do you hear the sound of them when I type or something? Is that the deal? Because it's not super loud. It's not one of those clicky mechanical keyboards. It's one that, like, you know, you could actually use if you've got colleagues nearby. Oh, Cameron's asking, a little off topic, but could you really quickly highlight what a STUREP is, or what the STUREPs are? Yeah, happy to do that, though. I think that's quite useful. The student representatives are people who are tasked with the job of communicating on behalf of the students with the school. So they are a really nice line for you to give feedback about how courses are going and stuff like that. So we've had times in the past where a course has gone a little weird, so gone a little off track, and a lot of the students have said, oh, there's a problem here. And there's different places where problems can come up. So I've seen problems come up on Reddit and on Facebook and stuff like that. And it's like, that's not really the best place for those problems to come up. So what we have as the student representatives are people who can bring the problems directly to the school. So the student representatives have a regular meeting with the head of school and the deputy head of school for education. And also myself, I happen to be part of that little committee. And they're able to point out the things that are happening. So if a lot of students are saying, hey, this particular subject is doing this weird thing and it's not really working for the students, it's much easier than trying to talk to the lecturer themselves about it. Sometimes talking to the lecturer themselves about things that are wrong with their subject can be a really daunting thing for students to do. So instead, you can say, hey, student representatives, you've got the ear of the head of school. You're supposed to be talking on our behalf. Can you ask them about this? Because it feels weird. I mean, that's the most polite way to say it. You could also be like, I hate this subject, it's crap. But, I mean, even when you do say that, you're still going to be listened to. Because if all you say is, I hate this subject, it's crap, but 18 other people are also saying the same thing, then we look into it, right? So it's the student representative's job to collect that information. So they have their open email address that you can just send anything you want to. So you can be like, Mark taught us functions, but then he didn't give us a code demo. And I understand that's a problem. And so now, between Wednesday and Friday, I don't know what I'm doing with them. That's okay, because there's no labs about functions until next week. So hopefully it's okay. But, you know, if you have those complaints, it's much easier to talk to them than it is to me. It's also much more constructive than it is talking on social media about it. Because if we just complain on social media, we already know that nothing happens. when we complain on social media. But if the complaints can go through a good channel to the source, then things can happen. And so it's kind of like, as students, you can skip us, in a sense. So you can skip the lecturers and go above them to the person, the two people basically who manage the lecturers, as in the head of school and the deputy head of school who's in charge of education. So you can have your complaints heard in a really good way. And I find that any complaints that go through StudReps get a much more effective turnaround than, say, complaints that just sort of go on Facebook. Because, I mean, like, there's not that many lecturers on Facebook. And so I might see something and go, ooh, student has a complaint. I hope that went somewhere else rather than just here. Because I'm not going to just take screenshots of Facebook and send them to the head of school. It's a weird thing to do. Whereas the StudReps are going to be able to take what people say and pass it along. So that was a longer answer than I was saying. But I think that's kind of useful because it's good to know what the StudReps are doing and how they can help you. There is an opportunity for yourselves, actually, to become StudReps. Because we will be holding elections at some point, probably around the end of this term, because what we do is we like to hold the elections after you as first years. I think the majority of people here are first years, have at least seen or met some people so that you can vote, rather than if we voted at the very beginning of term, it would be a little awkward. So you will have first year representatives for the next 2 terms of first year. Okay, hopefully that's enough information about what the StudReps are and what they are. Oh, Cameron's going to apply to be a StudRep. That'll be awesome. It's good. It's always good to have people applying, because I think it's a really useful thing to have, and especially hard, I think, for first year students to be represented. So I think it's a very important job. So thank you for applying for that. So let's go back to the questions. Dunyanda, I apologize if I have butchered the pronunciation of your name. Is there any trick to solve the pattern questions for loops? So we were doing loops where this is lab exercises for this week. Oh, I'm gonna try this new thing and see if it works. Oh no, I didn't install that on this computer. I jump back and forth between the computer at work and at home. At home, it's easier to do my lecturing because I've got my webcam and camera set up here. So I guess we're going to do this like this. Alright. So we're drawing a pattern, yeah. I'm going to do a really simplified version of this that's only got this 4x4 grid. So if we go, this is 0, 1, 2, 3, and this is most likely going to be 0, 1, 2, 3. So if I'm going to draw a square grid, and I'm drawing a square grid using these as my eyes, I assume, so my row counter here, and then my column counter here. So I could do these in rows and columns. I was going to do it as I and J, but rows and columns is actually kind of better. Actually, I'm going to make sure these are in different colors. So these are rows, and these are columns. So I know that my my loop going through is always going to know where it is. So I'm in row 0, column 0, and this one, for example, is row 1, column 2. So I should put a comma in between. I'm not going to fill out all of this table. You could fill out this table because you know how these numbers are going to work. What I then have is a pair of numbers in each of these cells. So if I have a pair of numbers in each of these cells, then I have something that identifies each cell exactly, which means I could be able to decide based on the numbers that I see here whether something should or shouldn't be drawn there. So let's take, for an example, I want every second row to be filled in. So I want every second row to have a star in it. I'm just putting the stars in the corner because I might be drawing some coordinates in here. So I want these to be stars and the rest of them to just be spaces, so they won't have any symbols. Then I can look at the numbers in here and say what mathematically is similar about these rows, and I might see something like this. I'm not going to bother writing the other numbers because they're not relevant for this particular example. The zeros get stars, the ones don't get stars, the twos get stars, the threes don't. And this is just on the row numbers. So I can say, ooh, in that case, if the row numbers are 0, 2, 4, 6, 8, they're even. If the row numbers are even, then they're going to get stars printed. Otherwise, they're going to get spaces printed. So I can do a mathematical question there, which is an if statement based on the variables of the rows and the columns as we go through this. And then based on whether that question is true or false, I can decide whether or not I'm going to draw something. So for example, the flow of the program, we're going to look at this cell first. So if we're iterating through rows, so we've got a while loop on the rows, and then inside the while loop on rows, we're looping through the columns. So what we're going to be doing is we're starting on this one here, and then we'll look at this one, then we'll look at this one, then we'll look at this one, and then we'll look at this one, then this one, then this one, then this one. That's the flow of how we're going to be looking at every element as we print it out, because you print out one line and then you go down to the next line and you print out that line. So I nearly said for loop. Our while loop here is going to be looping through the content like this, and in doing so, it's going to be able to see the two coordinates. I might put some other coordinates in here. So it's going to look at these and say, okay, I've got these numbers that identify this. I've got these numbers that identify this. Then I can ask a question about those numbers, and based on the answer to that question, I can decide whether I'm going to draw something in there or not. So if you draw up a little grid like this and you put all the numbers in, and then you look at the pattern you want to draw, and then you look for the mathematical reason why that pattern should exist, that should tell you something about what's about whether you should do something or not. Yeah, so hopefully that answers the question about how we might do something to decide what gets drawn and what doesn't in this kind of thing. Okay, so other questions. I'm just gonna scroll up. People are discussing different keyboard switches. Brendan was asking, can functions only have one output? Yes, functions can only have one output because of the nature of the functions. Ooh, that's not what I wanted to look at. People talking about PTSD earlier. Okay, the nature of the function is it sits somewhere in your code. So when this function returns, it gets transformed into something. So if it gets transformed into a value or something like that, like an integer, then it can only be one value. If we tried to have more than one value, then we would end up in a situation with, like, how, when this gets called, do we know which of the values to use to put into the total, for example? So it can only have one. So it has one output here like this. However, we will be learning later how we can get a function to kind of, it's not the same, but kind of have more than one output. So we'll see how that happens a little bit later on when we do a thing called pointers, but just wait for it. That'll happen later. Someone says, can whoever's using blues mute, please? That's the mechanical switches on keyboards that some of them are clicky, so they're really loud. I do like the clicky ones a little bit on the feel, but I ended up deciding that the welfare of everyone around me was also important to me, so that's why I have quiet switches. Alan's asking, is the printf function within the main function, or is it independently? Does it independently exist? The printf function actually does independently exist. Let's see if we can find it. I'm just looking up the source code for standard input output.h, and we'll see if we can find it. This could be really messy, by the way. So, standard input output.h, it's got a lot of includes and defines. We haven't even hit code yet. It's got all of these compiler flags about if this, then this. It's actually doing things for different computer architectures here. Oh my god. Okay. So, I don't usually look at this code because it's super hard, but let's just printf. fprintf, extern int printf. This is the one that we use. Right formatted output. Yeah. So, not all the details are here. You can see the ... There's other stuff in here. So, printf is here, and if we go down here and look for it, there's other printfs. Oh no, I don't think those are important. But here is where most of the printf is, and so this is actually where these functions will appear. They're not entirely here. There's other stuff that actually has the written code for printf, but this is kind of where printf exists in a sense. So it exists in this standard input output. What's happening when we do hash include standard input output is this entire file. What are we looking at? 900 lines, but that's not even everything that it uses, because it's actually it's including those, it's including all of these, it's including this stuff. So there's more stuff going on whenever it happens. But basically every C program you write has 1,000 lines of code at the beginning, which is this stuff, and then it runs your stuff. So it knows all of this, and this is just a kind of a partial example of how printf has actually existed as a function outside of our code, outside of our main, and then when we call it in our main, it jumps into here and goes, okay, where's the printf thing that you were looking for? It's probably going to jump to somewhere else because this is only one line. It doesn't actually have all the running code here. Not sure exactly where it is. I don't usually dig this deep into the libraries. People are still talking about keyboards. Yes, and Jason was answering that the printf is defined in the header file, standard input output.h, which is the one we just looked at there. Fenarius is asking, why is the main function an integer? It's actually kind of an old way of doing things that we don't really even use much anymore. Is the main function will give back some information about whether it executed correctly or not. And now that you know about return, you know that this return 0 that's sometimes at the end of our main is our way of signaling that the main function has exited from the proper finish. And we've actually looked at this a little bit before, where I returned 1 somewhere else when I thought that the main function hadn't ended correctly. So that was me saying the main function has reached a state in which it cannot end properly, and here I will give you a code other than 0. So the main's always been an integer so that we could signal something from the main. An integer is nearly the most basic type that C uses. It's not really, I mean, you could consider a bit to be even more basic than an integer, but most of the time when we're using, like, we want to give back some information but we're not sure what it is, it'll be an integer. So that's why your main still has an output, even though it's not really using it much, and we're not going to be using it much even in this course. So you can put the return 0, or you've seen in some of my main functions there's no return 0, because if it hits the closing bracket it will just return 0 on its own. Everyone thinks I should have brown switches on my keyboard. David was asking about how to kickstart a GitHub profile. I think that goes a little bit beyond 1511, so I'm not going to answer that here on stream. But you can talk to people about it. I think CSESOC are good people to talk to about this, because plenty of them have their GitHub profiles up and running and stuff like that. Oh, talking about GitHub. Yeah, yeah. Don't put your assignments on GitHub, by the way. We've had some hilarious problems with people with assignments for GitHub, which is that they were putting everything that they did for uni on GitHub because it's actually decent practice to do that, but they didn't realize that their GitHub was both public and labeled with the subject code of COMP1511. And so, like, I've had people who had no idea what was going on get pulled up in plagiarism investigations because they've accidentally put their stuff on a public GitHub. Hemi is asking, so we can define a function after we use. We can, in a sense that the function is defined here, but there's a difference between the definition, which is like the code of the function, and the declaration, which is the announcement to the program that the function exists. So, I mean, we could technically copy-paste this code up here instead of this, but this is the format we use, which makes it easier to not have to, like, do certain functions before others. Subtleties I'll talk about later. But the line of code that uses the function has to at some point know what the inputs and outputs of the function are. So this line will say what the inputs and outputs are, and that way we can check in our main whether this is correct or not. And we can only check if it's correct or not if we know what it needs. So minimum, this line has to happen before this line. We're talking about, I think Jason there was talking about input to the main and talking about /program with things on the same command. They call it the command line. So if you type in the program name and the command line and some other stuff, there's ways we can actually pull that into the program. We'll talk about that later though. Just going to teach one thing at a time. Lorenzo was asking about what are the 3 things that every while loop needs from the tute questions. That's happening this week, right? I think you can talk to your tutor about that one. But the way that... Do I even have any loops? I don't think I've even got any loops. Yeah, I've got one while loop here. So most of the time, it's not always going to be the case, but there's usually going to be a variable outside the loop. Actually, this one will do it. Variable outside the loop. A check, like a reason why we would stop, and a thing that advances the loop. So if you're going to think of 3 things, it's creating the starting point, creating the ending point, and making sure it progresses from one to the other. That's one way you can think about while loops. But I think your tutors are going to teach you this anyway. Someone was saying they're starting their loops at 1 instead of 0. It depends on the loop. You can start loops at anywhere and move them in any direction. So for example, if I want this to run 10 times, if I really wanted to, not sure if I should edit the slides here, but I could do this. Oh yeah, there's not even syntax highlighted. Minus minus goes in the opposite direction to plus plus. So I could say start at 10, count down to 0, and minus minus. So you can do them that way as well if you have a need of doing them that way. Usually if you need to go in the other direction or something. So say you needed to reverse the order of something, you might loop in the opposite direction. You could also say that I need to do a loop that starts at 10 and ends at 30 or something, so I need specifically those numbers. You can have your int I start at 10 and at 30. There's no specific reason why this has to be a 0, because you can see even in the dice examples, like the dice statistics that we did, it started at 1 instead of 0. The reason why we start them at 0 generally is this counter now knows exactly how many times the loop has run, and this here with the less than is exactly how many times it will run. So this is a kind of a way that we can say these numbers are significant to us in some way. And so I've got this comment in here that says the loop has run I number of times. right? So first time we get here, the loop has run 0 times. The second time we get here, the eye will remind us that the loop has run once. On Friday, I will show you another reason why we start at 0, but I'm not going to talk about that yet. Okay, just looking through the questions. Yeah, Nguyen Ha Chao is saying that they could start at 1, and this could... So you could definitely do this, where this starts at 1, and this is less than or equal to 10, and you would get the same result. The only difference is this fact of the loop having run that many times won't be able to be used in the same way. So it'll be like, you would, instead of saying it has run this many times before, you would say this is the ith run of this loop. So when you have 1 as the first one, it'll be this is the first run of the loop. So yeah, you could do it that way. Oh, oops. I'm undoing too many things. Go back to my while loops. Okay, but I think this is an interesting discussion, and things are open to you to work with. It doesn't have to be a 0 there. If you see a need for it that's other than a 0, you use it, right? So it could be like start at 100, count down to 50. And so you definitely wouldn't start it at 0 if it was 100 counting down to 50. You'd start it at 100 and you reduce it by 1 each time until it gets down to 50. I think that's the discussion that's happening in chat there. It was a long discussion in chat between people there. But yeah, lots of different ways of doing it. Edis, is it Edis or Edless? I'm not sure. I guess it's a nickname of some kind. Edis Ambrose says, why do we learn about while loops over for loops? We use while loops rather than for loops because if we're only going to use one loop, then a while loop is more effective than a for loop. A for loop has some nice kind of helpful syntax in terms of setting stuff up, so you're less likely to forget this thing in a for loop. Having said that, the while loop, if you've never done any programming before, the while loop is more useful because it just reads top to bottom. So you do this, then you check this, then when you get down to here, you do this, and then here you go back up, right? So you can read it line by line. It's much easier. Whereas a for loop kind of jumps around where it does things. So it has this line at the top where it has more details, and it does parts of that line sometimes, and other parts of that line at other times. It jumps back to that line when it reaches the bottom, but it jumps to the end of it, right? So it's harder to remember which bit goes when. Whereas the while loop is really clear because you can read it. So that's why if I'm only going to teach one, and a lot of the times when I'm teaching techniques, I will teach only one way of doing it, then I'll teach the way that is the most obvious when you're using it. So that's why I use while loops instead of for loops. I think in plenty of other places in coding where you're using C or C++ and stuff like that, you might use for loops instead. So if I was wanting to teach many different ways of doing things and I had the time for it, I would probably teach for loops as well. But it's not entirely necessary, right? And it also goes back to the idea that we're teaching programming and we're teaching computer science, and we happen to be using C to teach programming and computer science, right? So when it comes down to thinking about it in that regard, it's a little bit different, where I don't need to teach you every different possible thing we can do in C, which is why the style guide actually cuts out a lot of things, because I'm teaching you a subset of C so that you can understand how to code, and the language long term will be irrelevant, because at some point in the future C is going to fade out and people will stop using it. I mean, it's already much less prevalent than it used to be in the past. So we're teaching it to you because it's useful for learning, especially the second half of the course where things get weird, we start digging into memory. C is much more useful than other languages in terms of that, in terms of learning that particular thing. But if we teach you good programming practices and you can translate them into different languages, then that's the key. That's the thing that works the best. Okay. Yeah, I don't think there's any other questions. Yeah, it's actually most of the chat now is people answering each other's questions, which is really nice. Misspelt loves the blue switches. going click clack. Yeah. Okay, so I think that's all the questions answered that people had so far. Thanks for dropping by, and hopefully for everyone that stuck around, you got something useful out of that. I'll wrap it up there, and hopefully a lot of the stuff that we're talking about in loops gets clarified in this week's tutorials and labs, so you'll get a chance to practice them. There's actually a lot of looping practice. I will see you on Friday. On Friday, we're actually going to write some function code, but I'm also adding in this new thing, which syncs up with loops really well. They're called arrays. But talk about that on Friday. Alrighty. See you all. Oh, wait. Someone wants to see Chicken? Chicken's having a nap. Wait, let me just make sure I can see my camera. There, she's just sitting on that chair. Hey, Chicky. Chicken. No, not gonna work. But anyway, she's just having a nap. So there's your goodbye in a particularly cat way from Chicken, where she completely ignores you. All right, wrapping it up there. Thank you all. See you on Friday.